advanced fire protection alternative for future data centers. This is Victoria Valentine, SFPE's Director of Professional Qualifications and Industry Alliances. I'll be moderating today's webinar. Today's webinar is sponsored by Kidde Fire Systems in Marioff. Before we get started, we're going to review some of the specifics. First, all participants who are SFPE members will receive a certificate of attendance for 1 PDH. To receive a certificate, you must stay online for the entire webinar. Certificates will be sent out via email in about a week. Also, we do not provide copies of the speaker's PowerPoint presentations. However, we will be posting a video of this presentation on SFPE's YouTube channel and website in the next week. Additionally, you can ask our speaker questions by writing it in the webinar dashboard. You can ask a question anytime, however, we will be answering questions at the end of the actual presentation. Today's speaker is Jonathan Ingram, Mission Critical Vertical Market Manager for Kidde Fire Systems and Marioff North America. Jonathan has concentrated on the data center and telecom industries in the business development role. His responsibilities encompass evaluating the mission critical market, developing and managing strategic business relationships, and identifying areas for business growth throughout assessment of product, competitive landscape, and market needs. He has been involved with training and delivering presentations to end users, fire marshals, fire protection engineers, and distributors domestically and internationally since 1995. During his 20-plus year career, he has held various application engineering, product management, and sales management positions. Mr. Ingram graduated with a B.S. degree in electrical engineering from the University of Hartford and is a certified lead green associate by the U.S. Green Building Council. He serves as a principal member on the NFPA 76 Telecommunications Committee and as an alternate member on the NFPA 12, 12A, and 2001 Gaseous Fire Extinguishing Systems Committee, as well as membership chair of the Fire Suppression Systems Association. He also is a member of the Society of Fire Protection Engineers, 7x24 Exchange, and NFPA, amongst others. We're glad to have Jonathan with us, and I will now turn it over to you.
Thanks, Victoria. So I appreciate everybody taking the time to listen to me talk for the next hour on high-pressure water mist systems and water mist systems in general. So hopefully by the end of today, we'll be able to cover or at least answer some of the questions on the following topics. What is water mist? What is the different types of water mist systems out there? Because there are several different types of water mist systems in today's market. So we want to make sure that everybody understands what those differences may be. How does water mist extinguish the fire or control the fire? And many may be interested in hearing, as we said in the title of the presentation, protecting your cloud with mist. You know, how are we applying water mist systems to the data center environment and beyond in the future data centers? We'll also cover the approvals and how these type of systems are approved for use in the different applications that they are deployed into. We'll also cover the new factory mutual water mist data center approval, which is a modification that has come out to FM 5560, which talks about general water mist systems, but they've added some testing protocols and other types of things in there specifically for the data center environment. And then we'll cover a little bit more about the high pressure water mist systems. So to answer the first question, what is a water mist system? Well, if you look at NFPA 750, a water mist system is classified as a system that delivers a mist or a volumetric distribution of water droplets that are less than 1,000 microns in size, or roughly 1 millimeter, and basically 99% of the volume of the droplets have to be within this less than 1,000 micron diameter or smaller value. So there are three different types of water mist systems. You have low pressure water mist, which is anything that operates below 175 psi. You have intermediate pressure water mist systems, which operate anywhere between 175 psi to less than 500 psi. And then you have high pressure water mist systems that actually operate at pressures greater than 500 psi. Now, one thing to note that I've made down at the bottom of the slide is that the water mist systems outlined in NFPA 750 typically gain their pressure or their operating pressure and delivery pressure from either nitrogen driver arrays or compressed air, which could either be from a compressed air cylinder or compressed air that might be generated by an electric pump that pumps the water through, or provides pressure and pumps the water through the tubing out to the nozzle and delivers it at a specific pressure required to atomize those water droplets into the size droplets that for that particular system. So how does water mist actually extinguish the fire or control the fire when it operates? Well, the first thing is that it provides cooling. It cools the energy source, cools the fuel source down, so that fire can no longer exist. If you look at, for many of you are familiar with the fire triangle. Some may say it's a fire tetrahedron, but for explanation purposes, we always refer to the fire triangle. If you interrupt either the energy source, which is the heat, the fuel source, which is what is burning, or the oxygen that contributes to the fire burn, if you interrupt any one of those three, you typically cannot have a fire, or it will stop the combustion process. So water mist is acting on the energy. It's also acting on the fuel through the wetting process, so it's coating the fuel to make it less likely to burn. And then there's other things like radiant heat absorption. Radiant heat absorption is really a good quality of a water mist system because it helps control ceiling temperatures from getting astronomically high, which then can relate to or result in ceiling excessive heat at the ceilings, structural integrity, compromisations, those type of things. So this type of system is efficiently using these water droplets to control radiant heat as it gets into the ceiling voids. The other thing is that this system basically also extinguishes at the local level of the fire through local inerting, which is basically when we're discharging, or when the water mist is actually being discharged into the space, into those fine droplets. The heat from the fire is actually turning the water droplets into steam. And when that steam is actually created, it's creating a local inerting or oxygen-deprived envelope around that fire source and causing the fire to be extinguished from or starving it of oxygen, which is required to burn. So those are the four things that water mist really does when it is acting on a fire. Now, some of the things that are very important to define the effectiveness of the firefighting capability of water mist are a few things. Many of you are familiar with sprinkler systems and those type of things. Well, there are some similar requirements for water mist systems that are required for your traditional sprinkler systems. One is flow rate per unit area. We're always talking about K factors and how much we're flowing per or what the capability of the nozzle is for the square footage of that particular space. So that's similar to how water mist systems are looked at too during the testing phase. There's also what distribution, how the distribution of the flow rate is achieved, the direction of the application that we're trying to protect and apply the water to, droplet size and distribution. You know, so as I mentioned before, there are 3 different types of water mist systems. So droplet size and distribution, similar to, you know, other fire protection technologies, are going to be critical in how much of the area it can cover, how much the nozzle can penetrate down into the fire and provide the optimum protection for the fire condition. And then, you know, lastly, we talk about droplet velocity. So with water mist, you don't have a large droplet that relies on gravity to to drop into the fire core. You basically, through the pressurization, through the nozzles and everything else, you're creating a velocity of the water droplet. Therefore, allowing that the velocity is going to be important because it allows it to penetrate the fire core and cool the fire core down below its ignition temperature, and therefore either you extinguish the fire. Now, when water mist systems are actually qualified to be used in particular areas, they are basically qualified using the performance-based approach. This helps define what nozzle types can be used, what operating pressures have to be achieved, spacings that are required between nozzles, water flow rates, max installation heights, and max protected volume of the system. And these are accomplished by doing full-scale fire tests. It's not a one-size-fits-all test. So if water mist systems say that they can protect a data center, for example, they have to test to make sure that they can protect the area and the types of fires that we might typically see in the data center environment. Same thing for backup generator spaces. We have to protect and make sure that we can protect those type of machinery spaces and those type of things. So these are performance-based systems, similar to pre-engineered type systems that you might see using other fire performance technologies, where they have specific parameters that you're using to apply a particular extinguishing mechanism to an application. This is kind of the same approach. We're looking at all the different applications that could be out there, whether it be, again, data centers, backup generators, heritage applications, museums, hotels, you name it. All of those have to physically be tested in order to qualify or show that it can actually be effective in those type of environments. So one of the things that I have here at the bottom of the slide is that just because one test or a few tests have been done, water mist system A may not equal water mist system B, and therefore there is not a one-size-fits-all type of an approach. So one of the things that I would tell you to do is to contact whoever might be supplying your water mist system, if you're choosing to use a water mist system in place of a traditional sprinkler system, or in conjunction with it. That particular manufacturer can provide either third-party testing agency approvals, which could be UL or FM standards, to UL or FM standards, or that they have actually done some performance-based third-party lab testing at independent lab facilities that they can then produce that type of information to show that they are effective in those type of environments. So in the data center world, where could we possibly use water mist systems? Well, we could look at it as being used in the data halls, both in the above and below floor type areas. We could be looking to protect generator rooms, electrical and UPS rooms, battery rooms, network operation control areas, technical support areas, and then outside of the data center envelope of the white space that we're looking at, we could also protect office areas or administration spaces, within the building, because typically we're designing these systems similar to the way that you would apply traditional sprinkler systems into different applications. Water mist systems can carry, FM class hazard 1 or hazard class 1, light hazard class 1, and ordinary hazard classifications depending upon the type of water mist system that you're deploying into a particular area or from the manufacturer. Now, there are some applicable standards that apply to water mist systems. NFPA 750 is the design and installation guideline that has been created that governs water mist systems. Also, FM 5560 is a nationally recognized design and installation guide for applying these systems out there. Along with FM 5560, it provides fire test protocols, component test protocols, and then it issues an approval based upon the number of tests that have actually been passed as far as the application type from that. There are some. There is also some things with UL that does some fire test protocols, component test protocols, and approvals. For those of you that do international work, there are other agencies out in the international market that also provide certification or approvals of these type of systems, whether it be VDS, which is prevalent in Germany, GOST or VNIPO, which is in Russia, and a few other international standards there that do govern the applications of these particular types of systems. So let's talk a little bit about approvals and listings for the system, and particularly the FM 5560 approval, because really what everybody's what everybody's interested in is really learning about how we're applying these to data centers and what kind of things have been done to allow or prove that these can be applied into the data center realm. So FM approvals, which is the independent testing arm of the insurance carrier FM Global, came out with FM 5560 in 2000 earlier in this decade, and then revised the appendixes M and N for applications, to data centers and those type of things. The revision to the FM 5560 standard added 2 new test protocols for water mist systems intended for the protection of above and below raised floors in data center server rooms, or looking at protecting the data processing equipment halls and cable trays below raised floors. So why is this testing protocol important to the industry, especially when applying water mist type of technologies? Because as I mentioned before, water mist is a performance-based is performance-based to basically prove its validity in the different types of applications that are out there to provide and approve its effectiveness. Now, one of the things with this FM testing that was done or that's required is that when we're applying these type of water mist systems that get the FM approval, they are made to actually, or the protocol requires that we test with the forced ventilation still on. So the tests were run with the ventilation on, to reflect real-life conditions in today's data center environment to verify that the particular water mist system will be effective in these type of environments. So what type of areas have been tested, as part of this protocol? Well, they've tested, regular standard open area protection where you just have your ceiling grids of homogeneously spaced out sprinkler heads that are spaced roughly between about 14 feet on center, and showing that we can actually extinguish a fire in this, or that the water mist system can extinguish the fire in this particular type of an arrangement. The other thing that's been done is testing for hot aisle, cold aisle. Hot aisle and cold aisle is very prevalent these days in the data center environment, as many of you know, mainly because of trying to increase energy efficiencies, and cooling loads and various other types of things. So a lot more hot aisle and cold aisle configurations have been deployed into data centers to maximize the energy efficiencies and the reduction of cooling loads in these spaces, which has added a kind of a challenge for the fire protection industry in general, to making sure that we take into account when these systems are deployed, how do we want to design them? How do we want to space nozzles? Where do we want to, what other things do we need to take into account, from air velocities? And I mentioned earlier that we had to make sure that we could actually penetrate or get the droplet to penetrate into the core of the fire to allow for the cooling and everything else to take place. Those are the types of things that have to be validated during this testing that we are capable of, or that the water mist system is capable of doing in this particular environment. So this is just an excerpt out of the FM5560 test protocol that's available to everybody if they want to look up the protocol. But this just kind of shows some of the testing configurations and other types of things that are expected to be or that are deployed when testing against the FM5560 standard for data centers. This is also a picture that FM publishes regarding what the server hall test mock-up would look like and applying for the test of these particular water mist systems. So as you can see from this particular picture, this is actual picture of a test ongoing, at a particular, from a data center mock-up, and you can see it might not be as clear on the screen, but you could see it up in the upper left-hand corner. You can see the water mist head being activated and actually starting to provide mist down into the mock-up area from the fire test. Now, one thing I will tell you is that these tests will show or have results that may have different manufacturers of water mist systems either activating less or more heads to control the same type of fire. And it really comes down to how good the water mist system can control the radiant cooling aspect of heat generation at the ceiling level, and also allow it to control and extinguish the fire. That will determine how many heads at minimum will have to be used to control a certain fire source or within the data center environment. There's also some subfloor testing that gets done. Again, this is from FM5560, where what they do from a subfloor testing mock-up perspective and what is required to pass that test. This would be a representative mock-up of that test are what would typically be done in the fire protection industry when mocking up subfloor systems, whether it be for water mist systems or gaseous fire suppression or sprinkler fire protection or anything else. This is some of the things that have to be constructed in order to verify that those particular systems will work in this particular environment. This is just an example of what it might look like in the subfloor fire test when burning under floor cable trays or that type of thing. So, why do we want to consider high pressure water mist for the data center environment? Well, the first thing that high pressure water mist gives you is a lower water usage compared to the traditional sprinkler systems to control the same fire. We're typically talking anywhere between 60 to 90% less water used to control the same fire in the same space. When you use a water mist system compared to that. So what does this result in? This is going to result in reduction of collateral damage, related cleanup to water, which is going to help the customer get back into, recover from its downtime and get back up to work, operation quicker. You're also going to reduce the amount of maybe abatements that have to be done from water damage, whether it be mold abatement or those type of things. The other thing to consider is that if you have a data center that maybe it's not a large data center, but it's a data center that might be encompassing a floor of a high-rise building, one of those type of things that you would maybe be concerned about is the waterfall effect of water flowing from floor to floor to floor as the system's being discharged from a traditional sprinkler side. You may have that effect where with water mist, or high pressure water mist, because you're using such lower amount or less amount of water compared to the sprinkler systems, you're not going to have that water falling effect that you would have with the other system. So other things with high pressure water mist systems that gives a designer peace of mind is that not only can you protect the data center space and all of its surrounding support areas, but you can also expand it into other areas within the building. So in this particular graphic on the right-hand side, this is showing that you have the high-pressure water mist system up in the upper right-hand corner, and then all the tubing and nozzles are connected back to that pump via the stainless pipe. And at every different room, they're actually controlled. They have a directional valve or a zone valve or a pre-action valve, if you want to call it, keeping the water from flowing into the space until it's actually needed. But when you size a particular water mist pump, if you know that your customer or someone is going to be expanding their area because maybe they're going to build a certain section out right now, but then they're going to expand on a later date into future areas, whether it be that they're expanding the building from a physical construction standpoint, or they may have bought a complete high-rise or a telco hotel or something to that effect, where they may be expanding by floor. This type of system allows you to size the pump appropriately for those type of expansion considerations. And then as each of the phases come online, you're able to actually expand that system without having to add extra pumps and those type of things. And really it becomes adding just extra tubing to get to the spaces, extra pre-action valves for that, and then the additional nozzles that would be required to protect the additional spaces. Just to give you an example, there is a data center operator that is using high pressure water mist systems here in the U.S. that is they have a large pump in the basement of the building, but they have expansion plans to expand up to multiple floors as they build out space. So they are deploying this particular type of system, high pressure water mist system, because it gives them the total coverage that they need for the entire build out, which could be between 5 to 7 floors in height. So again, this, being able to know what your customer's expansion capabilities or what they're looking at from a data center perspective will help size the pump accordingly for the water mist system to be able to apply it to future expansions as that business grows over time. And it may be a couple years before that next phase gets built, or it could be a couple months, but at least it allows them to have that capability without having to, maybe space additional pumps, around the building because one pump gets exceeded or not on a traditional sprinkler system, or it doesn't have the capability of pushing up multiple stories, for the same protection. And it becomes very cost effective. So, once you've sized the pump, again, because you're only adding tubing, the pre-action valves, and the nozzles, after the initial investment in that particular infrastructure up front, it then becomes more of a cost-effective means of expanding the systems moving forward. So here, this is just another example showing that, off the same pump, you could potentially protect a data center space, the admin spaces, general assembly areas, anything that would be light hazard, consideration, or, HC1 classifications from FM. And one thing I will tell you as part of this, and this is the only piece that probably becomes more of a marketing piece, but the high fog water mist product is the first high pressure water mist system that was approved, has gone through the FM data center approval process and has achieved that approval through FM as of, I think, was February of this year. Now, the previous picture. So the previous picture showed the electrical, if you look down in the bottom left-hand corner, the previous picture shows a sprinkler or a water mist skid pump. This is basically an array of electrical pumps, and there are going to be different scenarios from different manufacturers, but each of these pumps is what creates the pressure in the lines that deliver the water mist at its delivery pressure into the space. So you have this type of pump. The other types of delivery mechanisms that you have are actually the gas-driven pumps, which are basically driven by either nitrogen or compressed air. So depending upon what your application is, you might be able to get by with either a compressed air or nitrogen-driven gas pump arrangement, or for the larger areas which you're actually trying to protect, from larger footprints, maybe 250,000 square feet or 100,000 square feet or larger, then you're going to want to look at that electric pump or the sprinkler pump unit. Now, one thing I will tell you is that the nitrogen gas arrangements or the compressed air gas arrangements, to my knowledge, at this particular point, there isn't anyone that has a data center approval for this particular type of an arrangement. But again, as I always tell everybody, check with the manufacturers that you're dealing with, to check their listings, check their third-party test reports, and various other types of things. Now, one thing, I just bring this up here because it's a good segue, because when we talk about gas pump units, people automatically think that, okay, this gas pump unit is dumping a lot of nitrogen into the space and with this water mist system, and therefore really looks almost like a hybrid system. So there's a water mist system, and then there's a hybrid system. So a water mist system, as I stated before, according to and by the definition of NFPA 750, gets its pressure, its delivery pressure, its operational pressure, either from compressed air, nitrogen driving, or nitrogen compression, or through electric pump units. Hybrids basically kind of do two things. They basically use nitrogen as a means of extinguishment, but then they also use water as a cooling mechanism. So there is a little bit of difference between water mist and hybrid, because with the water mist system, if you're really using nitrogen or compressed air, that does not contribute in any way to the extinguishing capability of the particular water mist system, where the hybrid relies on nitrogen inerting and also water to extinguish on its side. With the traditional water mist systems that are outlined in NFPA 750, these type of systems can actually be used for primary fire protection. So in different places in the world and even here in the US, there have been replacements of traditional fire sprinkler systems with water mist type systems to protect those ordinary hazards or those local hazard applications or light hazard applications with that. Another difference between your traditional water mist systems or high pressure water mist systems or water mist systems in general is the primary extinguishment is through local inerting. So we're not taking down the entire room volume, or the room volume with these type of systems is not being completely oxygen or reduced oxygen in those spaces to extinguish the fire. Where on a hybrid system, because it's using nitrogen as part of its extinguishing mechanism, it is acting similar to the way inert gases work, where they have to reduce the oxygen levels in the space down to about 12.5% to 16% O2 for the entire enclosure, where again a water mist system is really doing local inerting at the fire source. A water mist system, since it can be the primary fire protection system in a building, it can be designed to meet the sprinkler discharge requirements that are put out there by either FM or UL or anything else to meet the timing of discharge requirements by the different approvals that you need or the authority having jurisdiction. So if you need a 30-minute discharge, the water mist system's just sized to do a 30-minute discharge. If you want 60, it could be do 60. If you want 90, it can do 90. So it's just, there's two things that you can do with these systems is the size of the system or the what's being chosen, or what technology you're going to choose on the high pressure water mist side or the water mist side in general, whether you're going to use a electric pump or whether you're going to use gas driven pumps or those type of things. It's the duration of the required discharge is going to help you figure out what technology you want to use as far as the pump goes. Now with hybrids, because they're relying on nitrogen inerting and those type of things and bringing oxygen down in the space on top of the water being discharged from that particular system, they're mainly used for supplemental fire suppression systems. So it would be used in addition to a traditional sprinkler system because they're typically only supplying fire protection or discharge durations between 3 to 5 minutes in duration. So I thought it would be good just to kind of cover this from a differences between hybrid and water mist perspective, because when people see gas cylinders for gas-driven units or gas-driven pumps, they kind of associate that to hybrid. So I thought that that would be a very good topic to cover, just to kind of help clarify a few things and avoid some confusion. Now, one of the other things that high-pressure water mist systems use is that they use stainless steel tubing, because it allows the stainless steel tubing is really, it's really sized or actually constructed for the high pressures that are required by these systems and can withstand those high pressures of these systems. Now, one of the other things that it provides is it provides corrosion resistance. So we don't, with these type of systems, even if we're using pre-action type of arrangements where we have to show the flow of the water to the head, and then we have to drain it out, and those type of things, we don't have to be concerned with the MIC, or the microbiological induced corrosion that we see in traditional sprinkler systems, and that we've seen with having to add nitrogen generators to inert the pipe to prevent corrosion in those type of traditional sprinkler systems. And because we don't have to worry about the MIC or the corrosion internally within the pipe, we don't have to be worried about blockage concerns or flow concerns over the lifetime of the system. Basically the water will flow freely to the nozzles. You're also, with these type of systems, you're discharging clean and clear mist. They're not going to be discharging, again, when you have corrosion in a pipe, you might be flowing rust and other types of things through the pipe out the discharge of a sprinkler head, where these type of water mist type systems, they're actually providing clean water. And the clean water can either come from a potable source, so it can come from your main municipality into the pumps, or you can actually have a tank stored system. Now, one thing I will tell you with these particular, with water mist type systems, is that they will specify a particular, maybe a particular water quality spec, because as different impurities in the water or different additives to water, whether it be chlorine or various other types of things, can add to how system performance and those type of things. So there will be a water quality specification associated with these type of systems from that perspective. Now, because we don't have to worry about corrosion, the other thing that it also removes over the lifetime of the system with water mist is pinhole leaks. So in a data center environment, everybody's really concerned about leaks over the servers or the critical equipment over time. And if they have to replace, sections of pipe at a time, that becomes more of a issue when you're working in a working data center that can't afford to have a mishap over their servers or that type of thing. So this also gives you the capability, or these type of systems gives you the capability of not having to worry about those over the duration of the system. Because you're using stainless steel tubing, and also you're working at a little bit higher pressures, the tubing can be fit into confined spaces around obstructions a little easier because they can be bent and formed and connected in a sense that gives it a little bit more flexibility to those type of installations. So again, it helps blend in with the surroundings. It helps gets around obstructions, and it also blends in with the surroundings. So in summary, and I know we're getting close here we've got about 15 minutes more before, and I want to make sure we have enough time for questions and answers. The benefits of high-pressure water mist systems in the data center environment really comes down to these bullet points here. It allows you to phase in a construction approach. You don't have to worry about, well, am I going to have enough later in the tank to basically protect all the other areas that are planned to be expanded to, but are not going to be expanded at this particular time. So you can have a peace of mind of scalability. The other thing you can have a peace of mind on is design flexibility. So giving you the capability of having different routes and imbalanced systems, and maybe piping up higher, through multiple floors, from a lower level, giving you that capability to do that. Being able to accommodate hot aisle, cold aisle, above floor, subfloor, plenum areas, generator spaces, those type of things. And another critical thing is lower water consumption. I can't hit on this enough. With that's the benefit of high pressure water mist systems, is using a smaller droplet to have the same effectiveness on a fire condition that a traditional sprinkler does. And this is becoming, water consumption is becoming a very, very focal point when it comes to data centers, because they're all trying to reduce their environmental footprint, whether you're talking to and hearing some of the public presentations that either Google has done or Facebook or any of those particular clients. They have an environmental focus that this may fit into that particular, this type of technology may fit into that particular type of environment. You're minimizing the downtime and cleanup because you're not discharging as much water. Just to give an example, when we say less water or low water consumption due to downtime effects, a traditional sprinkler system is flowing somewhere around 18 to 20 gallons per minute out of a nozzle. Water mist is maybe flowing, a high pressure water mist system might be flowing anywhere between 6 to 8 gallons per minute. So you have a significant less amount of water that's actually being discharged from that high pressure water mist system. You can also have, with high pressure water mist systems, depending upon the manufacturer, you can have pre-action setups. You can have deluge setup. You can have a wet configuration, wet pipe configuration off the same pump. So you don't have to have different things to do different areas. You can have multiple types of systems, basically, or whether it's pre-action, deluge, or wet pipe, coming from that same pump. It's safe for the occupants. It's not going to lower oxygen levels in the room as a whole. It's going to lower it only oxygen at the fire source only. When you're dealing with the stainless steel tubing or the high pressure tubing, you don't have any corrosion issues that you have to be concerned with over the lifetime of the system. The pipe, for all intents and purposes, is easy to install. It's also easy to, get around, certain obstructions and other types of things that we all know that when we're going into a data center, maybe to retrofit, or when we're building a data center, depending upon which trades get in sooner or later, sometimes piping runs have to be changed. So we have to make sure that we can, allow ease of installation. There's effective cooling. You can use potable water or tank stored water. A lot of these systems have upfront filtering capabilities where they're taking out a lot of the impurities from the water source, whether it be sediment or other types of things, before it gets into the system. So you typically have an inlet filter. You have a filter before it actually gets into the piping, and then you have filters, in the nozzles for all intents and purposes, to assure that you're getting that clean discharge. It's environmentally friendly, and there are no chemical additives. So If one thing I just wanted to kind of show a little bit of, and it's about a 4-minute video, and then we'll get to questions and answers, is a video that kind of shows the high pressure water mist system. But the thing I want everybody to kind of pay attention to is it does have some marketing piece to it. However, there are some educational points, just kind of reaffirming through pictures and other types of things, some of the topics that we've talked about today. So I'm going to play this video. Can everybody hear this?
Jonathan, I don't think the audio is coming through for the video.
Okay. All right. Well, maybe what we should just do is we should just, I'd rather, if there are any questions and answers out there, maybe we should just go right to questions and answers. And if anybody, wants to view the video at a later date, they can contact me and I can make sure they get copies of it.
Okay. We do have some questions that have come in if you've reached that point.
Sure. We're ready to go.
All right. We've gotten quite the variety of questions so far. So, and of course, if you still have one, you're welcome to send it in and I'll read through it. So one of them that came in is how effective is water mist at pre-wetting adjacent fuel if the mist is primarily turned to steam?
Okay, so the water mist. The question is how effective is the water mist system at pre-wetting fuel if the adjacent water is turned to steam? Correct.
Adjacent fuel, so just basically where beyond the origin of the fire. But yeah.
Yeah, so it would be effective, in that scenario, because basically the water mist system has to be able to not only in most cases extinguish the fire, but also has to be able to control the fire from spreading to adjacent fuel sources. It's basically we're providing full fire suppression from that aspect. I don't know if that answers the question or not.
I think it gives some additional information. I got a couple of different variations on the question, but there's a couple of people out there asking about, could this system be applied in an electrical room? Areas of transformers, main panel boards, switch gears, and if so, are there additional precautions that are needed?
Yeah, so yes, so you can apply water mist systems into electrical spaces, into transformer areas. Actually, we, from our own experience, which I'm going to grab from, there has been outside transformer protection, inside transformer protection with these systems. You just have to basically make sure that particular water mist system that you're using has a testing approval, or at least some sort of test report that shows that they've actually run the tests and have been successful at extinguishing those type of fires. But from our perspective, yes, you can protect electrical rooms, transformers, and everything else. And with a high pressure water mist, because you have such tiny droplets, some of the things that we have found is that you get lower electrical conduction that some people are concerned with, that would be for people's safety and those type of things. You don't get a lot of electrical conduction that is damaging to the equipment or to the people in that room, or that may be in that room.
Great. So I have one, and there's been a couple of questions that are very much installation oriented. So I have one here that's asking about the duration for water supply for a water mist system. And I also just, on top of it, because there are a few questions that relate to installation, is there where does the installation information come from for this type of system?
So the installation for these type of systems come from the design, installation, and operations manual that are published by the water mist manufacturers. For that. Now, the water mist manufacturers also, on the second part of that question, if you're looking at a particular application and how things have to be applied, that comes down to the performance-based scenarios that each of the systems had to qualify their system for that particular application. So some water mist systems, as I mentioned before, for the data center space, may require less nozzles in a certain coverage area. Others may require more nozzles to cover the same coverage area. So that is going to be a key differentiator when you're looking at from the installation side. The other question I think that was out there was the duration of water supply, which I think is probably asking how much water do we actually need for this particular system. So if you're using municipal water, that municipal water, as long as you have the supply coming in from the municipality and you have, you're using like one of the electric pumps, you could have an infinite amount of protection and supply into the room with that particular pump. Now with the gas, like a gaseous or the gas-driven pumps, those particular ones would be sized. We would have to size the amount of nitrogen needed or compressed air needed to drive the pump for the required duration of the system. So that would be something, the duration of protection is going to be decided by the authority having jurisdiction or the type of hazard or those type of things. So, but the system would be configured to supply water around the requirements of the hazard.
Great. I do have, I think I can fit two more in our few minutes that are left. So one of them is asking about, looking for your opinion on water mist and the amount of damage, and the way I'm reading it is from water that you would experience with IT equipment and so on. I think kind of just in a comparison to what we would see with other types of systems, whether it's a sprinkler system or a gaseous system or clean agent, but just kind of where does it compare on the damage of equipment?
I would have to say that it is less damaging to the equipment than a traditional sprinkler system, simply just because we're flowing less water. Whether you're running like underfloor cabling or that type of thing, the biggest issue with underfloor cabling is typically with a sprinkler system, unless your subfloor is sealed, you're typically allowing the water to collect under the subfloor. And as that water gets up, it actually soaks the cable, and therefore may require, the cable to have to be repulled or the subfloor dried out, or the equipment in the immediate area of the discharge of the sprinkler had to be replaced. Where the water mist, we're doing a lot of, again, you're using 60 to 90% less water than a traditional sprinkler system. So you are going to have some water, but the water that you're going to see is going to be more like a dew, I would say, than more like a flood, if that kind of puts it into a visual perspective.
And any comparison to non-water-based systems, gaseous or clean agent?
So water mist is kind of the in-between, I would say. It has its, for large areas where people, we're seeing a lot of larger data centers going to pre-action sprinklers and those type of things. So this type of system would actually be economical for that particular piece. The gaseous, of course, is going to have the least amount of damage because of the fact that it's a gas. And it basically is it's a gas, and that's what the premise of a gaseous fire suppression system is is basically to, you know, is to put the fire out and to, you know, discharge into the space and get into every nook and cranny. The water mist system, you know, will have less damage than a traditional sprinkler system would, and actually would be, for all intents and purposes, I think it would be, you know, gaseous would have least amount, but water mist would be right behind it.
Okay. So the last question that I am just going to squeeze in is, I had a couple of people, we have quite a few international attendees today, and they're asking if this system really is available globally. I know Peru was one of the places that wrote in, and I'm not sure what the other couple of countries were, but we've had a few ask that.
Yes, yes. Water mist systems in general, I can speak for ourselves. Our, you know, the high fog system is available worldwide. So it's just putting them in touch with the right people.
Okay. Well, you know, Jonathan, thanks. That was a great presentation, very informative. And thank you to all of our participants and attendees who have been listening to us today. Like I mentioned at the beginning of the session, the video will be available on SFP's YouTube channel, and you'll receive your certificates via email. And thanks again to Jonathan for today's great presentation.
Thanks, Victoria. I appreciate everybody attending.
All right. Have a good day, everyone.